Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is Hydraulic Modification Question Bank. In these previous lectures, till now, we understand, according to as a part of discussion of tutorial questions, this hydraulic modification we are going to understand. This is also one kind of modification which we are going to do for getting the desired soil properties. For getting the desired soil properties, we are going to understand these hydraulic modification techniques based on the hydraulic conditions on the soil ground. So in this, already we know ground improvement techniques for soil properties, enhancing the soil properties, or getting the desired soil properties as per the requirement of the project. In that, different kind of techniques are available. Different types of modifications we categorized in that: mechanical modification, hydraulic modification, and so on. In these, now we confine this lecture for the hydraulic modification. How we are going to analyze the question according to the hydraulic modification point of view. In that, how we are going to analyze it. So we will see in this class. So in this, the first one is explain the process and objectives of preloading and surcharge in ground modification. How does this method help in soil improvement, and what are the key considerations during its implementation? Sometimes the question may or may not be this much clear. They explain the process and objectives of preloading and surcharge in ground modification. So according to in that particular situation, as per the marks allotted for this particular question, we are going to assess the answer. So in this, they clearly asked how this method help in soil improvement. It means in which point of view that particular technology or technique, how it, the way of getting the desired soil property and the output. Like this, we are going to understand the technique. How does this method help for the soil improvement? So what are the key considerations during the implement? In these also, some considerations may require. So in any kind of implementation process, some considerations are there. In this particularly, so many considerations. Some of them are minor, major, like that. So many considerations are there. In that, here they ask about the key consideration during its implementation. So in this, the first thing what they asked is the explain the process and objectives of preloading and surcharge. Here we are having two different terminology. The one is preloading and surcharge. So here first we have to consider the process of preloading and surcharge. Whatever the technique it is, the first step is the site preparation is the starting process for any kind of technique, whether it is any kind of categorization also, whether it is mechanical modification, whether it is hydraulic modification, any kind of physical modification, any kind of inclusions or confinement modifications, whatever it may be, the site preparation according to type of the modification, type of the category, we have to ensure the site preparation is one of the primary step which we have to conduct in our ground improvement techniques process. So in this, as per the preloading and surcharge, the one is the site preparation here, clearing and leveling the site to prepare for preloading. So the preloading, we are loading that particular area wherever we require this soil enhancement or required modifications in properties. Not only all properties, here also the desired properties means in which some of the properties are going to modified as per the project requirement. So in this, the preloading before the process is going to start, we are doing this process. So the preloading, and for that the requirements are clearing and leveling of the site to prepare for preloading. The next step is placement of surcharge load. So applying a temporary load, often in the form of soil, sand or gravel, over the area to be improved. So we are applying the temporary loads in the form of soil. We may apply in n different types of loading process are there, but here in this particular technique we are applying temporary loads in the form of soil, sand or gravel over the area which we are going to improve. In this, the placement of surcharge load, we have to understand it is in the form of, in which form we are applying this preloading also important. It depends upon the which type of technique we choose for that getting the desired soil properties. In this, so the placement of surcharge load we are applying as a temporary load, in that which the load how we are applying are also some often form is we applied, that is in the form of soil, sand or gravel over the area to be improved. The next one, the monitoring. Installing instruments to monitor settlement and pore water pressure during the preloading period. In this, during this preloading period, so here we are doing this technique before the process starts. So in that, the monitoring is important for this preloading. Here, installing instruments to monitor settlement and pore water pressure during this preload period, we have to understand. So what kind of changes, what kind of modifications are we are getting based on these temporary loads. As a part of preloading process, we have to monitor to settlement and pore water pressure during this period. The next one is the consolidation period. So we have to allow some sufficient time for the soil to consolidate under the applied load. So we have to allow some time, because of we are not applying any kind of dynamic forces in that. There is no kind of dynamic loading situation in this particular preloading condition. So here we are applying some other soil we are using, or gravel as per the modified, as per the required properties, as per the getting the required properties, which type of preloading is suitable, we are doing that. In some of the situations soil is enough, in some of the situations sand we may apply as a temporary load as a sand, sometimes gravel. It depends upon the for getting the desired property. So here for this particular situation we have to allow sufficient time for the soil to consolidate under the applied load. So this period can vary from a few months to several years. It depends. Why? Because the settlement, so any voids, any pores, any some fillings are required, whatever it may be, depends upon the type of the material which we choose. It took some time. So depending upon the soil properties and the thickness of the compressible layer, in the how much thickness we are providing this compressible layer also plays a role for getting that sufficient time. So this period, it may vary from months to years. So in this preloading, we have to understand these are the steps we are going to form. Next one is the removal of surcharge. So here we are applying the excess surcharge load. So here we are removing once the desired consolidation is achieved. So because of this only we are getting this monitoring. So once the monitoring is going to done, once we understand the desired consolidation is achieved, when we remove this surcharge load. So first we are applying the excess. It based on the thickness, it depends upon the whether it is sand, soil, any other gravel. So after getting these consolidation, we are going to remove the excess surcharge. Load we are removing after getting the consolidation. This is the process. This is the process. In this, different types of objectives are involved. Those are reduce settlement, increase bearing capacity, mitigate liquefaction are the main objectives of these kind of preloading and surcharge. So in this reduced settlement, preloading accelerates the consolidation process, reducing the post-construction settlement. So this is one of the important parameters. So in this, what we have to understand is reduce settlement. Once we done the construction, we completed the construction work and everything without doing this kind of technique, it may occur. The post-construction settlement we may happen. So for reducing such type of post-construction settlements, we are accelerate these preloading conditions for getting the desired consolidation. So this is the one of the important objective. The next one is increase bearing capacity. So by preloading the soil, its bearing capacity is improved, making it suitable for supporting structures. Mitigation, liquefaction. So preloading can be helped to densify loose saturated soil, reducing the risk of liquefaction during the seismic events. Whenever any kind of seismic effects are happening in that particular region, reducing that risk of liquefaction because of this preloading, it can help to densify loose and saturated soils. So it is going to densify these kind of soils. Those are loose and saturated soil. It lead to the reducing the risk of liquefaction whenever the seismic events are happen in that particular region. These are the main objectives of preloading and surcharge. In this, according to the question, we have to understand what are the key considerations. So here we understand, in this we understand how does the method help in soil improvement. So we may observe in this, it is help to improve the bearing capacity and accelerated the consolidated process, reducing the risk of liquefaction. We may give another heading and we may write according to the thing. So it like that we have to understand. So this is the process and objectives once done. How does this method help in the soil improvements? We may write like this. After this, we may put a heading based on the type of this technique. Whatever the technique it is, based on this technique, it increase its soil bearing capacity and also it helps to densify the loose and saturated soils. Like that we may represent the answer as per the given question. Now one more important thing is the key considerations. So soil properties, load magnitude, monitoring and instrumentation, and environmental impact. These are the considerations for this type of technique. In this soil properties, understanding the soil characteristics such as compressibility, permeability is a crucial for determining the preload duration and magnitude. So once already we discussed in this, it took some period of time. How much period it is required? It is depends upon the soil properties. Based on those characteristics, based on those, especially compressibility and permeability plays a role for determining the preload duration and its magnitude. So based on this compressibility and permeability only, we are going to understand the preloading duration and its magnitude. Now load magnitude. The surcharge load should be carefully calculated to ensure sufficient pressure is applied without causing instability. So this is also one more important consideration. Now monitoring and instrumentation. So regular monitoring of settlement, pore water and soil behavior is essential to assess the effectiveness of the preloading process. If you want the effectiveness, so the regular monitoring of settlement and this pore water pressure gives the better results to assess the preloading process. And environmental impact. Consideration of potential environmental impacts such as surface runoff and erosion is important during the implementation. So like this, we are going to understand these process and objectives of preloading and surcharge. How does it help and what are the key considerations during its implementation? Like this, we are going to understand these type of questions. Now move on to the describe the dewatering process in hydraulic ground modification. Whether they mention these hydraulic ground modification or not, describe the dewatering process is also enough. And also different methods of dewatering. What are the various methods involving in dewatering and in what scenarios are they typically used, and there where we are used these kind of dewatering technique. So in this dewatering, the name itself tells something. We are dewatering. We are reducing the water content in that particular. Reducing water content, dewatering. So in this, based on this removal of dewatering involves the removal of groundwater or surface water from the construction site or excavation to create a dry and stable working environment. So for this purpose, we are choose this dewatering technique. So this process helps in improving soil stability and preventing water related issues during construction. So the process helps in improving soil stability and preventing water related issues during construction. So for this, the major purpose of choosing this dewatering technique. So improving soil stability is very one of the important parameter whenever the groundwater level is high and it required foundations in deep foundations are there. So in that such conditions, preventing water related issues during the construction. For that purpose, we are going to choose this dewatering process. In this, so what they ask different methods. So in this dewatering, we have n different types of methods. Those are well points and deep wells. So these are the methods, different methods we are used according to the various scenarios. In these well points and deep wells, educator wells, sump pumping, horizontal drains, these are the various types which are involved in this dewatering process. In this, the first one is, one of the method is the well points. Well points. In these well points, a series of small diameter wells are installed around the excavation area and water is pumped out using a vacuum pump. So according to these well points, we are identify the various points for getting the excess water into the out. At the time of excavation surrounding the whenever we are going to construct that particular area, a series of small diameter wells are identified the points and we are installed around the excavation area, and such type of wells are installed once. Now we are pumped out the water using the vacuum pump. In that, this kind of method we are choose for shallow excavation and low lying groundwater levels. In that particular scenario, so for shallow excavations and also lowering groundwater levels, we are choose these kind of well points dewatering system. And also other method is that is deep wells. In this, so the previous well points are the series of small diameters. Coming to these deep wells, large diameter wells are drilled and submersible pumps are used to extract the groundwater. This we are choose for the larger diameter wells are drilled and submersible pumps are used to extract the groundwater. In this, these kind of water system, deep wells, deep watering system we are choose for deep excavation and areas having high groundwater tables. So whenever high groundwater tables are there and suitable for deep excavation, it is effective in variety of soil types. So in that particular scenarios, we are choosing these deep wells as a method of dewatering. Whenever deep wells and high water tables are there, in these submersible pumps are used to extract the excess water. Those kind of wells are the large diameter wells are drilled. And other method for dewatering process is Utica wells. In this, a network of wells equipped with jet pumps is installed using high pressure water to create a vacuum and draw water out from it. So here we are creating high pressure water to create a vacuum and draw water from it. So these kind of wells method, dewatering method we are applying whenever ideal for soils with low permeability. Whenever the condition of soils with low permeability, ideal for soils with low permeability such as silts and clays, where traditional water, whatever the dewatering methods are less effective, in such types we are choose this type of technique. The other method is sump pumping. So in this sump pumping, water is collected in sumps, in pits and pumped out using centrifugal pumps. Such type of sump pumping, it is simple and cost effective method for managing surface water and minor groundwater intrusion in shallow excavation. And also horizontal drains. In these horizontal drains, in these horizontal pipes or drains are installed to intercept and redirect groundwater away from the construction site. So these kind of hydraulic drains are used in slopes and embankments to prevent water accumulation and improve stability. So these are the various different methods which we are chosen for the dewatering. And what are the particular scenarios and their applications we will see in detail. In that construction site, whenever the dewatering is essential for creating a stable foundation and preventing water related issues during the construction, such type of construction sites we are going to choose this dewatering techniques according to the site condition. Already we understand for shallow excavation, deep excavation, high water level, low permeability conditions, choose according to the type. So we are choosing the choice is depends upon the conditions. Soil and groundwater conditions. For choosing the method. So in this, next one is the tunneling and excavations. In that, ensures a dry working environment, preventing flooding and soil instability. Such type we are choosing these kind of dewatering technique. The choice again it depends upon the soil and how the level of groundwater is there. So based on that we are choosing the dewatering. The next time is land reclamation. So removing excess water from reclaimed land to improve soil properties and support infrastructure development. And also agriculture projects. So lowering groundwater levels to prevent waterlogging and improve soil conditions for agriculture also we choose dewatering systems. The next one is what are the principles and applications of the electro-osmosis in hydraulic ground modification? Discuss its advantages and limitations. In this first we have to understand the electro-osmosis in hydraulic ground modification. What type of principle involved in this electro-osmosis and what are the advantages and disadvantages. In this, principles of electro-osmosis involves using an electrical current to move water through fine-grained soils. Electrodes are inserted into the soil and a direct current is applied, causing water to migrate from the anode to the cathode. In this type, so these principles of electroosmosis involves using an electrical current to move water through fine-grained soils. So these electrodes are inserted into the soil and a direct current is applied, causing water to migrate from anode to cathode. So this principle is involved in these electroosmosis. In these applications, so what are the applications? Means dewatering in fine-grained soils, stabilizing soils and excavations, contaminated site remediation. These are the some of the applications which we observe. In this, effective for dewatering silts, clay and other low permeability soils where traditional dewatering methods are less efficient. So we have different types of dewatering traditional methods. Those are less effective. So in such type, we are choose these kind of technique we are use for this dewatering process. So in this, the next one is stabilizing soil slopes and excavations. In this, used to reduce water content and improve the stability of slopes and excavations. This electroosmosis type technique is the advanced technique for dewatering process. It is not a traditional dewatering method. It's not a traditional dewatering method. It's not a traditional dewatering method. So in this, we use it to reduce the water content and improve the stability of the slopes and excavation sites. So the contaminated site remediation, electroosmosis can aid the removal of contaminants from the soil by enhancing the migration of pollutants towards the electrodes. So in this, electroosmosis can aid the removal of contaminants from soil by enhancing such type of pollutants towards the electrodes. Based on this principle of electroosmosis, we are dewatering whenever those traditional methods are less effective. So these are the some of the applications we choose for this electroosmosis. Coming to the advantages of these electroosmosis, it is effective in low permeability soil and also it's a controlled process, minimal disturbance. In this, effective in low permeability soil. Why? Because it provides an efficient method for dewatering and stabilizing the soils that are challenging to treat with conventional techniques. It is a controlled process because the electrical current can be precisely controlled to achieve desired results. So we are precisely and we are controlled the whole process because of this electrical current. We are precise control to achieve the desired result. And also minimum disturbance. Electroosmosis causes minimal disturbance to soil structure compared to the mechanical methods. And also it has some limitations because of the energy consumption, electrode maintenance, limited depth, environmental concerns are also there in this electroosmosis. In this energy consumption, the process requires a continuous supply of electrical energy. So the continuous and required precise electrical current, the process is we have to maintain, which can be costly. Without fluctuations, without disturbance, without fluctuations, we have to maintain the electric current. So this is the one of the disadvantage. So because of this, the energy consumption is the one of the limitation. In this process, the continuous and prescribed, particular, the required and controlled the flow of this electrical current is somewhat difficult. It gets the energy consumption to supply the continuous, so which can be costly. And electrode maintenance, these electrodes can corrode over time. So because of these electrodes, the maintenance of electrode is also one of the difficulty which we are faced in this electroosmosis technique. Why? Because these electrodes can corrode over time. So requiring maintenance and replacement. So the continuous monitoring is required for this electro-osmosis because of this electrode maintenance. Otherwise, they are going to corrode over the time. So whenever the maintenance and any replacement is required, we have to done immediately. Otherwise, it affects the whole process. So this is the one of the limitation which we understand in our this electro-osmosis. In limited depth, so the effectiveness of electro-osmosis decreases with the depth. Whenever the depth is going to increase for getting the dewatering, this effect is less. So making it less suitable for deep soil applications. So for shallow and somewhat it is adjustable for the depth. Whenever we are moving into the depth, so it is difficult to get the effectiveness using this electro-osmosis technique. And also environmental concerns. The use of electricity continuously may pose, it creates some environmental concerns, particularly in sensitive areas. Depends upon the such areas. The consumption of energy is also one of the environmental concerns. So it affects. So this is also one kind of limitation which we observe in this electro-osmosis. Any kind of question, as per the question point of view, we have to understand the principle, how it works, and applications where we are applying this kind of technique generally we may require, and also advantages and disadvantages. We are going to write any kind of, this is the process. How much we are writing, where we are going to stop, it depends upon the, based on the marks. So this is the one kind of thing. The next one is the process ground freezing. This is also same kind, how we are implementing. In this, the process, first we are understanding the process. The question is discuss the process and applications of ground freezing in hydraulic ground modification. What are the benefits and challenges associated with this method? So here they didn't ask about the advantages and limitations. They are asking benefits and challenges. These are also some sort, but the way of representation is different when compared to whenever they are asking advantages and limitations. Benefits and challenges is little different representation is required. So process of ground freezing. So in this, the first installation of freeze pipes, that is the one of the first step. Next one is circulation of refrigerant, formation of ice barrier, maintenance of frozen condition. This is the steps which we are involved in our ground freezing. So in this ground freezing, freeze pipes are installed in the ground around the area to be frozen, typically in closed loop system. In closed loop system, it is somewhat typical. So whenever we are used ground around the area to be frozen. So and the next step is circulation of refrigerant. So in this, a refrigerant such as liquid nitrogen or brine is circulated through the pipes, lowering the temperature of the surrounding soil and water. Formation of ice barrier. The soil and water around the freeze pipes are freeze, forming a solid and impermeable barrier. It is termed as a barrier. And next one is maintenance of frozen condition. So we have to maintain this formation. So the refrigerant continues to circulate to maintain the frozen condition throughout the duration of the project. So this is the process which we involved in this ground freezing. Whenever we are applying tunneling and excavation, shaft sinking, contaminated site remediation, these are the applications which we use this ground freezing. The one is tunneling and excavation. So creating a stable and watertight environment for tunneling and deep excavation in water bearing soils. Because of these barrier, it is easy to complete the project without getting any kind of disturbance. Shaft sinking also supporting the construction of shaft and deep foundation by preventing water ingress and soil collapse. So whenever we are doing such type of supporting shafts and deep foundation, so the prevention and soil erosion is happened because of this, using this ground freezing technique. And contaminated site remediation, isolating and stabilizing contaminant soils to prevent spread of pollutant during the remediation activities. So these are the applications which we use these ground freezing techniques. Move on to the benefits. So effective water control provides a highly effective method for controlling groundwater and preventing water ingress in challenging conditions. Temporary solution. So the frozen barrier can maintain only for during the project. So it is one of the benefit. It's making it a flexible and reversible solution. Minimal soil disturbance. So ground freezing causes minimal disturbance to the soil structure, preventing its integrity. Challenges. High energy cost, complex installation, limited depth and duration, environmental impact are the major challenges which we observe in our ground freezing. So the continuous circulation of refrigerant requires significant energy, leading to the high operational cost. And also the installation freeze pipes and maintaining the frozen conditions requires stabilized equipment, and expertise is also its complexity in the installation process. This is also one of the challenge which we face using this ground freezing technique. And also it is also the ground freezing is typically effective for limited depths only. So the during make it less suitable for long term or deep excavation. So whenever the project is long term, it is not suggestible. It's facing so many challenges. And also whenever deep depths also, this is not effective. Not whenever the required desired properties we won't get in deeper depths. So that is also one of the challenge which we face in our ground freezing technique. And one more is the use of refrigerants and the potential for thermal impacts. We are doing the freezing and thawing everything. So, and we are reversing after completion of the project. Environmental concerns are there. Those challenges, those impact we are facing because of this using this ground freezing technique. So further getting the desired properties of the soil as per the requirement of the construction work. So in this, the use of these refrigerants and potential for thermal impacts to this on the surrounding environment must be carefully we have to manage. This is the one more major challenge which we face in our ground freezing technique which we use. And move on to the next question. So explain the principles and applications of vacuum consolidation in hydraulic ground modification. How does this method improve soil properties and what are the advantages and limitations? So the one is, first we have to explain the principle, write out what are the applications which we understood, how it is going to improve, where the particular properties, and we choose where it is the properties are there, which type of property is going to benefited or getting modified using this kind of technique which we used, and what are the advantages and disadvantages. In this, principles of vacuum consolidation. So vacuum consolidation involves applying a vacuum to sealed area to remove pore water from the soil. So promoting consolidation and improving soil properties. This process typically installing vertical drains and covering the area with an airtight membrane. So this is the principle which is involved in this vacuum consolidation technique. So in this we are going to apply soft soil improvement, pre-loading for construction, infrastructure projects. These are the some of the applications which we use, or we choose this vacuum consolidation as a technique. Soil improvement technique. Soft soil improvement, enhancing the properties of soft compressible soils such as clay and silt. In clay and silt, we may use these kind of ground improvement technique to get the desired properties. And also pre-loading for construction. So preparing sites for construction by reducing settlement and increasing soil strength. The next one is infrastructure projects. So used in the construction of roads, embankments and foundations on soft ground. These are the some of the applications which we use. We choose this ground improvement technique, that is vacuum consolidation. So improvement of soil properties. On what kind of soils or what kind of properties we are going to modified. The modifications will be done. Some of the properties, those are using these kind of technique, vacuum consolidation technique. Those are increase effective stress and it enhances the shear strength, reducing the settlement. These are the properties which are going to modified using this kind of vacuum consolidation technique. In this increased effectiveness, the vacuum reduces pore water pressure, increasing the effective stress in the soil and promoting the consolidation. It promotes the consolidation. And the next one more important soil property which is going to modify, that is shear strength. It is going to enhance. So consolidation leads to improved shear strength, reducing the risk of soil failure. So this is also one of the modification which we observe using this kind of vacuum consolidation technique as a ground improvement technique. And reduced settlement. Accelerated consolidation reduces the long-term settlement, ensuring the stability of structures. These are the properties which we are going to modify using this kind of vacuum consolidation technique. What are the advantages using this technique? So accelerated consolidation, uniform improvement, environmental benefits. So it vacuum consolidation speed up the consolidation process compared to the traditional preloading methods. Because of this preloading, it took several time. It may affect the project time also, construction schedule. So it various things are involved in that preloading method. Moving to this vacuum consolidation technique, it speed up the consolidation process. And uniform improvement. So provide uniform consolidation over large areas also. The consolidation, it should be uniform using this vacuum consolidation technique, ensuring consistent soil improvement. And also environmental benefit, it reduces the need for additional fill material. As like preloading, it's not required any kind of filling material, minimizing the environmental impacts and material cost. This is also one of the advantage which we observe in our vacuum consolidation. Coming to the limitations, complex setup, energy consumption, site-specific effectiveness, membrane integrity. These are the limitations which we observe in this vacuum consolidation technique. That complex setup, the installation of vertical drains and airtight membrane requires careful planning and specialized equipment which we require. So the complexity of setup is in there. This is the one of the limitation which we observe in this technique. Energy consumption. Maintaining the vacuum requires continuous energy input, leading to the operational costs. And also site-specific effectiveness. The effectiveness of vacuum consolidation can vary based on the soil properties and site condition. And also the membrane integrity. Ensuring the integrity of the airtight membrane is crucial for maintaining the vacuum and achieving the desired result. These are the limitations which we observe in this technique. So like this, we are understanding the various types and their principles, applications, and how the process which is involved, disadvantages, benefits, and challenges, like that. Any kind of terminology they may use in our question. So according to the given question, we are going to divide and we are going to write our answer as per the question. So first we have to understand the techniques. After that, what are the principles and where we are going to apply, and also which kind of properties we are going to modify using that particular technique. So that particular technique affects or any kind of confined it is there only for particular soil, this kind of technique is suitable or not. So these are all the parameters which we are going to understand at the time of examination. So this is the end of the module 3, that is hydraulic modification. These kind of questions. This is kind. So according to that, we have to understand any kind of technique they may ask, we may write like this. So we will see the 4th module in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.